Alrighty, guys, let's go over this problem, and then after that, I'll give you guys the rest of the class period to work on the Unit 3 review. Okay, so like you guys know, the first thing that you always want to start off with is balancing the equation. So we're going to go over how to balance, because I know that some of you guys are having a little bit of trouble with this still, and that's all good. But first thing you want to do for your stoic problem, which is what's going to be on your test, is balance. So we're going to look at this equation right here, and we're going to figure out what elements are inside of this equation. So you just need to look for the capital letters. So we have Na, we have H, and then we have O. So these are the three elements that are inside of this equation. And we know because of the capital letters, Na, H, and O. All right. Alrighty, now we want to count them up. So if you take a look at this equation, we have one Na, we have two H's, and we have one O on the left side. And on the right side, we have one Na, we have one O, we have one H here and two here, so we have a total of 3. Okay. So I'll stop right there. Any questions on how we counted up the elements? Are you guys chilling with that? Okay, so what we want to do is the rules for balancing. The first rule is you want to add to the side with less. Okay, so if you guys don't know how to balance, make sure you guys write this down somewhere. You want to add to the side that has less or fewer of that element. Okay, so if you guys take a look at the table, we have one Na on both sides. We have one O on both sides, but we have an uneven number of hydrogen, right? We have 2 on the left and 3 on the right. So we want to add to the side with less. So we want to add to the left side, okay? But we can't just add the element by itself. We have to add the whole molecule. Okay? You want to add the entire molecule. So if you look on the left, the hydrogen is inside of H2O. So you have to add the whole molecule. You have to add H2O. Okay, that's going to change our numbers on the left. Now we have 4 H's because we added 2. So we changed the number to 4. And then we got 2 oxygens on the left. All right, so H is still not balanced. And now if you notice, O is also not balanced. So we have a choice here. We can add NaOH or we could add H2. Which one do you guys think we should add? Yeah, you want to add NaOH because if you do that, that helps you fix your H and your O at the same time. Because if you guys notice, if you add NaOH, now we have 2 NAs, we have 2 oxygens, and we have 1, 2, 3, 4 hydrogens. So that fixes our H and O, and we can fix Na very easily by adding 1 more. That'll balance it out. So that's how you want to balance out your equation. And on your exam, the difficulty for the balancing will be about this difficult. Okay, I picked a problem that's pretty similar to this one. So I know some of the balancing can get really hard, like on the review, some of the numbers go to like 3 and 4, but on your exam, I'm going to keep it to about 2. Okay. All right, and then we just put numbers in the front. So we're going to put a 2 in front of Na, 2 in front of H2O, and 2 in front of NaOH. And these are called coefficients. It just tells you how many of that molecule you got. All right, so that's step 1. Any questions on the balancing? I like how now that we have the test next week, everyone's actually paying attention. Yeah. Yeah, this one right here, right? Yeah, you put a 2 because you have 2 of the entire molecule. And so and since there's 2 in that molecule, if you put a 2 in the front, that's going to get it to 4. Yeah, good question, of course. All right, so I'm going to erase a little bit just so we have a little bit more room to work with. And this is being recorded, so if you miss anything, it's all good. It will be posted on Canvas. Okay, step number 2 is you want to find the molar mass of the important chemicals. Okay, so now we have to read the problem. So in the problem, it says that we have 50 grams of sodium, which is Na, And we already know that if we have a number next to that element or molecule, that's an important chemical, right? So Na is going to be important. So I'm going to put a star here just to keep that in mind. And then it says that we have excess H2O. Excess means we have so much, we don't need to worry about it. So that means H2O is not important. And then the problem is asking us to find the mass of both products. Okay, so in a chemical equation, whatever you have on the right side of the arrow is going to be the product. Okay, and so here we have two different products. We have NaOH and we have H2. So in this problem, you're going to be doing stoichiometry 2 times. One time, you're going to do a problem where you go from Na to NaOH. And then there's going to be another time where you do Na to H2. So you're going to be doing 2 different stoichiometry problems. Okay, and on your exam, that's what you're going to have to do as well. That's why we're going over this problem. Okay, so if you guys ever see the term both products or all the products, you're just going to be solving for everything on the right side of the arrow. Okay, so let's find the molar mass of all of these compounds. So the first chemical that we have is Na, and luckily Na is by itself. So if we go to the periodic table, we look at Na. The number next to N or underneath Na is 23. Okay, 22.99, which we can round up. So Na is going to be 23 grams per mole. Now, I'll give you guys about 2 minutes. I want you guys to work with yourself or with your partner, and I want you guys to calculate the molar mass of NaOH and H2. So take about 2 minutes to do that. We'll go over them together, and then we'll set up step number 3. Take 2 minutes to find the molar mass of NaOH and H2. Alrighty, guys, I'll give you maybe 20 more seconds to finish up the molar mass, and then we will go over it together. Are you going to share some of that with me? I don't. What are you eating from there? What are you eating? Huh? Why is it odd? You don't like McDonald's? Dude, McDonald's is the best. The best thing about McDonald's is it tastes the same no matter where you go. Legit the same. The quality's not very high, but they're very consistent. Yeah, they have different menu items. But so I lived in India for a month and I had McDonald's there. Dude, the McChicken tastes exactly the same. It's unreal. I was so shocked. All right, let's go over the molar mass for these guys here. So we already know Na is 23 and we have O and H. So we just go to the periodic table and look at, oh, H is right here. H is 1 and O is 16. And so all we need to do for NaOH is to add 23 plus O, which is 16, plus 1, which is hydrogen. And that's going to give us a final answer of 40. So NaOH is going to be 40 grams per mole. All right, and then H is really easy. H2 is just 1 plus 1, which is 2. Yeah. All right, so those are the molar masses. Now we just need to do the dimensional analysis. Now, here we're looking for both products. So you're going to have to set up the fractions 2 different times. So you're going to have 6 total fractions and 2 different calculations. So I'm going to start off with the first one where we're going to go from Na and we're going to go to NaOH. Okay. So let's set up our fractions. Our starting number is 50 grams of Na. So 50 grams of Na. We always want to start by setting up 3 different fractions. Okay, and then what's the weird noise that we make? Yeah, gmumaga. So G grams, M moles, M moles, and G grams. Gmumaga. And please don't yell that out during the middle of the test. I've had people in the middle of a test be like, gmumaga, gmumaga, gmumaga. And it sounds like they're going crazy. All right, and here we're looking for NaOH, so we put NaOH on the very last fraction because that's what you want to end up with. And then again, the trick that I like to use is the first two fractions are about the same chemical, and the last 2 fractions are about the same chemical. So we have Na for the first 2, and NaOH for fractions 3 and 4, like that. So some tricks that you guys can use to fill out more of the fractions. That way we can make it a little bit easier. Okay, let's start filling out the bottoms. I want to get rid of grams of Na. So if I want to get rid of something on the top, I put it on the bottom. The numbers come from the molar mass. So what we're going to do is go back to step number 2. We said molar mass of Na is 23. So we just put the numbers into this fraction. We put 23 next to grams and 1 next to moles. And that's going to let us cancel out grams of Na. Okay, next, we're going to get rid of moles of Na by putting it on the bottom of the fraction. That way they can cancel out. And you're going to get the numbers here from the balanced equation. Okay, so you just go to the balanced chemical equation and look for the numbers in the front. The number in front of NaOH is 2, so we put a 2 in the front here. And Na also has a 2, so we put a 2 on the bottom. And if we do that, the moles of Na can cancel out. And if you notice, we have a 2 on the top and the bottom, right? So if I have a 2 on the top and bottom, those can also cancel out, which makes your math a little bit easier. And then lastly, we're going to put moles of NaOH on the very bottom. You're going to get the numbers from the molar mass. And so we calculated that to be 40. So we put a 40 next to grams and 1 on the bottom. That's going to let us cancel out moles of NaOH. Okay, so if you guys notice, another pattern that you guys can use is it kind of goes in diagonals. Do you guys see that? The units of measurement, the red and the blue lines, it kind of goes in diagonal. So you guys can use that to make sure that you guys got the correct answer as well. Okay. All right, let's plug it into the calculator. So remember, you multiply everything on the top and divide everything on the bottom. So we start with 50. 23 is on the bottom, so we divide it by 23. And then we could skip the second one because everything got crossed out, times 40. Your final answer is 86.95, and I'm gonna round that up to 7. So your final answer is 86.957 grams of NaOH. Okay. So there you go. That is your first dimensional analysis. But since we're trying to do both products, you're gonna have to do it one more time in order to find H2. Alrighty, so I'm gonna give you guys 3 minutes. See if you guys can set up the other dimensional analysis. You're gonna start with 50 grams of Na again, and then this time instead of finding NaOH, you're gonna turn it into H2. So take about 3 minutes to set that up, solve it out, and then if you guys can get that, then you guys should be in pretty good shape for the test because it's gonna be about this difficulty of a problem, okay? Take about 3 minutes to do that, and then we'll go over it, and then we'll be all done for today. I can't, my foot hurts.
How do you, on docs, how do you put the subscripts in there?
Oh, you press Control, I believe, comma. Yeah, Control, comma.
And that'll put the number in. Control comma. Okay. And then this is a plus, and then the regular.
Yes, sir.
Okay. Control comma.
Control, comma. And then if you want to go exponent superscript, it's Control period.
Control comma.
Yeah, Control, comma, Control period.
Okay.
Yeah, it's yeah, it's different on Windows.
Okay.
Windows better. I'm very anti-Apple. Yeah. Even though I'm a shareholder. Yeah, I'm very anti-Apple. Alrighty, guys, I'll give you another minute to finish that up, and then we will solve it together. Alrighty, guys, let's go over this problem and then we will be all done for today. And I'll get you guys started on the review, okay? All right, so here we are gonna be doing the last dimensional analysis where we go from NA and we're gonna go to H2. But I wanna show you guys a trick that you guys can use to do less work, okay? So if you guys remember, we always put gamma on the top of the fractions, right? No, you chilling. I know you are a scholar. All right, so we always want to put gamma on the top of the fractions, right? Now, if you guys notice, we're still starting with Na, right? And then we said the first two fractions are going to be about the same chemical. So we can actually copy down these first two things exactly the way they are. The only thing that changes is the chemical we're looking for, right? And so what that means is we only need to change the last part of the dimensional analysis, and we just need to change it to the chemical, the new chemical we're looking for, which is H2. So we can literally just erase the last part and put in moles of H2, grams of H2 on the top. That way we still have gamma. We put moles of H2 on the bottom so they can cancel out. And then for the second fraction, balance the equation. H2 has a 1 in front of it, so we put a 1 here. And then the molar mass is 2, so we just put a 2 there. Okay, so if you want, if this is helpful for you, makes it a little bit easier to solve out the problem, you can just do this. Because if you do this, you can literally just copy down what you had before and then just recalculate using the new compound, okay? All right, so here we can just do our calculations. If we want to make it even easier, there's 2 on the top here, 2 on the bottom, and they can cancel out. So the only thing you need to punch into your calculator is 50 divided by 23. That'll give you a final answer of 2.174. Okay. So if trick makes sense to you, you guys can use it to solve it out. But if it does confuse you more, I recommend still doing the normal 3 fractions, setting it up the normal way. That way you can make sure you guys have the correct answer. Okay. Yeah. Correct. Yeah. Grams of H2. All right. So this is what your exam question is going to look like. There's only going to be one problem on there that's almost exactly like this. You just need to balance molar mass and do 2-dimensional analysis questions. And that's going to be where all the points for the exam comes from. Okay. So you'll see more examples like this on your review today. So you guys can get started with that. Let me know if you have any questions or if you guys want to check your answers. But I'll give you the rest of the class period to prep for the test, which again is going to be next week on Thursday. All right, good luck, guys. You're welcome. But when I say good luck, I mean, please fail so I can have you again next year because I love all of you so much.